Hello, everybody, and welcome back to the Future of Blockchain University Hackathon. Firstly, I hope you all had a really good weekend, were able to relax, and are ready for week 2 of the university hack. I'm just going to give it another 30 seconds or so, just to allow any late joiners to join and not miss any of the content. So another 30 seconds and we should be good to get going. But yeah, really great to see you all. Great to see you back for another week of workshops. And I hope you've all got some exciting ideas about some really cool projects that you can build. I see everybody saying hello in the chat. Hi, everybody. Good to see you all. And I will just invite our speaker to the stage. So just as Greg is joining, I guess we can kick off. As I said, it's really great to see you all. I hope you did enjoy your weekend. I hope you're ready to go for week 2. I've been posting messages in the Discord channel to outline kind of all of the workshops that's taken place this week. So we're really happy to see that you've decided to join us on this Monday afternoon. Hi, Greg. Good to see you. I'll just let you get set up whilst I continue with the intro, but I don't actually have too many notifications for everyone other than to just say really well done for an amazing first week. It seems like lots of you are already starting to think about your projects, think about what you can build, and hopefully many of you have found teammates for those of you who are looking to do some group hacks. For anyone who hasn't, once I pass over to Greg, I'll share all of the normal links into the chat. We really do like to hear how you're getting on. So even if perhaps you haven't got any questions for us, we'd love to book in a call just to hear how your project building is going. But I think that's everything from me. So without further ado, I'd love to hand over to Greg, who you all met at the launch event last Monday. I'm sure it's going to be an amazing workshop on integrating ENS. And yeah, Greg, I'd love to invite you to open the session.
Sweet. Thanks so much for the intro. I'm excited to kick this off. I have a number of slides set up to walk through a bunch of things, and then some coding demos if you want to get into it. So excited to go through the whole thing. I'm going to share my screen over here in just a second. Cool. Let me know if you guys can see that. It seems to be good.
Awesome. Yeah, that's good.
Cool. And then I guess anybody in the chat, I'm curious if you guys have heard of ENS before, have used ENS, maybe have an ENS name. I'll give you a few seconds to comment something if you have heard of it. And if you haven't, also totally fine. We'll walk you through everything today. I see a few people typing. And sorry if I keep looking back and forth. I've got 2 monitors over here, so I'll try and keep it pretty simple.
I will also do my best to shout out any questions, Greg. So if I do see any, I'll let you know.
Great, thank you. Cool, heard of it, but never worked with it. Not yet. Own one, still need to set a primary. Okay, cool. So we have a range of people in here, which is great. So I should be able to answer all of the questions and teach you some things. And so I'm excited to get started. So today we're going to be going over ENS, right? And what that means is we're going to be talking about what is ENS, why is it important, who uses it, what are the different types of ENS names, and so on. Really just what is it, how to use it, why would you want to use it, and then we actually will do it. Cool. So first of all, what is ENS? ENS is a decentralized permissionless naming protocol that lives on Ethereum and scales the entire internet. So I'm sure a lot of you guys are familiar with DNS, right? It turns IP addresses into domains. So if I just type ping google.com in my terminal and I get back this IP address, I put it in my browser and it will bring me to google.com, right? This problem with crypto is actually even worse. And so ENS aims to solve that. This is a very simplified view and we'll get more into it. But basically I have a long Ethereum address in this example, and it just points to gregskril.eth. And that's the high level. ENS is naming for Web3 and crypto. Cool. So the idea is anywhere you read or write an address, you should be able to use an ENS name. And so that means you're never using an IP address anywhere on the web. right now you do use crypto addresses as well as ENS names, but over time, I think if you just look at this example right here, it's pretty clear that a name to a name is a much better kind of visual of what's happening rather than a name to an address or an address to a name and so on. So this is another example of what it looks like to actually be using an ENS name, right? I'm in a wallet right here, MetaMask, if you all are familiar, and I want to send ETH to somebody, and I want to type in their name. I don't want to copy and paste their long address there. It's just a better user experience. And really, ENS started as this idea of a Web3 or a crypto username, but over time, it's becoming this Web3 profile. And that really just means a username with some more metadata underneath. And so you'll see here, if this is the view when I connect to a bunch of different applications, like crypto applications, right? If I scroll down this list, it's just a preview of when I log into these apps, how it kind of greets me. And it greets me as Greg Skriloff of ETH, my Web3 profile, rather than just a random string of numbers, which has no personality attached to it. And so you'll actually see this across a big number of Web3 applications today, but these are just a few examples to really show you what that feels like. Cool. And this is another representation of ENS as a profile, right? It's not just address to name. You can have a name, you could have an avatar, a description, a website, these other accounts and text records, which I'll get into later. But it's really just this idea that ENS is your portable Web3 profile. All of these websites over here, like Greg Skriloff of ETH is kind of my corner of Web3, and a bunch of different applications will recognize me as that and give me different capabilities based on kind of the properties of my name. And so why is this important? You might be thinking it's kind of cool, but why does it actually matter? And I think there are a number of reasons, right? Like ENS is fun, it's cool, portable, extensible, works across the chains, it's a public good, it is decentralized, but ultimately, like I've touched on, it improves the crypto user experience. So if we take Ethereum up here in the top right corner, that is the Ethereum logo, ENS, the ENS logo is really just a friendly wrapper around Ethereum. And I think this is a good way to really visualize and just get the vibe of what ENS is meant to do. You know, it's meant to be a friendly wrapper on top of Ethereum and the crypto industry overall, and provide a better user experience. Cool. So given this, we know ENS is cool. We know why it's important, but who uses it? And the answer is a lot of people, right? This is just a small snippet really from the integrations part of our website, ens.domains. And I can keep scrolling for a while, but the takeaway is a lot of teams already are including ENS in their applications because it provides a better user experience. And so if these teams are doing it, then I think you might want to as well. And so we will get into how you can do that in a few minutes. But first, again, I want to highlight ENS is for really everyone and everything. It's unopinionated. It's for hackathon projects. There are venture-backed startups being built on ENS, whether that's marketplaces or services or really any sort of company. And then publicly traded crypto exchanges like Coinbase are building on ENS to provide their users a better experience. So ENS is for everyone and everything. And in order to accomplish that, in order to actually be available for everybody to use, we have to have a few different types of names and a few different ways that people can get these names. So I would generally break it into 3 categories, and there are probably like subcategories of each of these, but at a high level, I break it into .eth, subnames or subdomains as most people call them, and then DNS. And so you might be asking like, why is DNS on an ENS list? But we will cover that in just a second. So first we have .eth. .eth is the, lives on Ethereum mainnet. It is fully decentralized, meaning no single company or team or individual can control anything about it, which is a difference between ICANN and the DNS system. It's owned and operated by the ENS DAO, which means all of the smart contracts that control ENS and .eth specifically can only be updated when there is an ENS DAO vote approving that change. And so this happened recently, of which I'm happy to get more in detail with if you guys have any questions. So yeah, also feel free to add some questions in the chat as I'm going through if something pops up, and I will definitely cover it in just a few minutes. Cool. And then importantly with .eth, similar to some DNS names or all DNS names, is that there is an annual protocol fee to prevent squatting. So a .eth name, or I should say a second level .eth name. So in a name that is example.eth, example is the second level part, right? And .eth is the top level. There's a $5 fee $5 annual fee to prevent squatting. This is simply so that I couldn't go, or somebody couldn't go and register all the names in existence and just sit on them and try and sell them to secondary people. We want to have a healthy namespace, and really the only easy way to do that is to have a fee. And so that is generally how .eth works. It's great in terms of being decentralized and totally controlled by the community voting, but because it lives on mainnet, it can be quite expensive during certain periods of time. And so options are really the thing that I want to highlight here, especially with off-chain names. Okay, and so you might be wondering, like, ENS, I just said lives on mainnet. It does all these things. It's fully decentralized. It's permissionless. But I want to make the kind of distinction that .eth or ENS is more than just .eth. So .eth was the original kind of name offering in ENS, but over time we've expanded this to be more just like scalable with the rest of the internet. And now I'm going to start hinting into my next workshop, which I think is on Friday, and we'll go really deep into this topic. But at a high level, off-chain subnames are exactly what they sound like. It's a subdomain that does not exist on-chain, and what that does is unlocks a number of, again, user experience benefits. So because it's off-chain, any developer can set these up for free. There's no ENS protocol fee at all. It allows developers ultimate flexibility into however they want to name their users or provide naming capabilities to their users in their apps. It's made possible by an Ethereum spec, so an ecosystem-wide spec, not just related to ENS, that was developed by the ENS team. And it's already being used by some of those huge companies that I mentioned before. So Coinbase uses this to issue free ENS names to all of their Coinbase wallet users, which is over 2 million people at this point. And they pay $0 to the ENS protocol. Lens does a similar thing. They have their social media protocol where they have, I think, over 100,000 users, and all of those usernames are ENS names for free by default. And so this is just a really interesting and cool way to infinitely scale ENS. And I see we have a question here. Subnames still could be on-chain. Yes, they certainly can be. They can be on-chain through either .eth or DNS, which we will get into in a second. But again, this is just like an option, not the only way of doing things. So very good question, and thanks for making me point that out. Cool. And so yeah, the off-chain names are really going to be the focus of my workshop on Friday. So I'm just going to touch briefly on it here, but if you're interested in that, then please stay tuned for the next one. Cool. And then lastly, I would say we have DNS importing. So ENS is not of the mindset that like the current DNS system sucks, let's throw it away, we want to replace it. That's just not practical. You know, everybody uses DNS every day. Right now, we're all watching a live stream on livestorm.co, and we just simply probably wouldn't be here if DNS and that domain did not exist. And so domains are great. We want to extend domains, not replace DNS domains. And so we allow anybody to import their DNS domains for free. Again, because ENS is a public good, it is not in the business of making money. Actually, it's not a business. And so wherever the squatting problem is not on our hands, like I said before, then we allow names to be created for free. So this is currently possible today. I can import a .com, .xyz, pretty much any DNS name into ENS for free as far as the protocol is concerned, but it costs a lot of gas. And I'm not sure how deep into Ethereum you guys are yet, but sometimes this gas can be quite pricey. And so during some periods of time, it could be hundreds of dollars of gas just to prove that I own a DNS name, which then allows me to import it into ENS. And so it doesn't really matter if we say it's free as a protocol, that gas is being spent by the user. And so that is a bad user experience, which kind of counteracts what we're trying to do at ENS. So using some really cool stuff, which is related to how the off-chain subnames work, actually. And again, I will dive into that in the next workshop. You will soon be possible to import these DNS names completely for free. And so what that means is you go into GoDaddy, you enable DNSSEC, which is like extra security on your DNS name, and you set a few text records, as in like TXT DNS records, and your DNS name just works as an ENS name. And so you would be able to go into MetaMask and send ETH or an NFT or any sort of asset to example.com. And the user or the owner of example.com does not have to pay any money to enable that at all. And so again, this does not exist quite yet, but is coming very, very soon. And so I wanted to highlight that as I think it's exciting. Okay, we have another question here. This one's a bit longer. You mentioned multi-chain, but I found some concerns about the use in L2. Yep. So good question about using ENS for multi-chain stuff. And I think once I get into the more technical, maybe coding part of this, I'm happy to like click through the docs and poke holes at things. Generally, the idea is like any application, regardless of what chain it is. So if it's mainnet Ethereum or Arbitrum or Optimism or anything like that, you can always look up a name on layer one. And so, for example, I have like my address is the same across mainnet and all the layer twos. And so really you just want to see if my name exists on mainnet, even though the user is connected to layer two. And this includes like the reason that you have to look at mainnet as kind of the source of truth for all ENS stuff is because this idea of replication across layer twos is really kind of just not possible right now. And ENS works by having a core registry where all the names are in sync, and you just can't have that registry in sync across layer twos yet as like a general ecosystem-wide problem. But you would totally be able to, in like a recipient field or some sort of input, accept an address or an ENS name and just check to see if that name exists on layer one. And so maybe that answers your question. If not, we can dive deeper into it. But the kind of overview, TLDR, is that you would be looking up the name on layer one as the source of truth for all ENS stuff today.
Greg, we've also had a question in the question channel. You can click on the bottom of the page, but it basically says, what's an example of an off-chain subname? I assume this just looks like a standard ENS name.
Yep, exactly. So I can actually, I'll get into it later, but I will drop a link in the chat for now if you want to poke around. This is more, I think, aligned with the next workshop, but I'm happy to touch on it in just a few minutes when we get to the coding part as well. And yeah, it works based on this EIP, which again is an Ethereum level spec, not just an ENS spec. And it provides a way for applications to fetch data off-chain kind of transparently and securely. And so, yeah, I could dive deeper into that in a minute, but hopefully that helps as a starting point. And I have that demo link that will show you just like a tangible example of how it works and actually let you do it on the spot. Cool. So yeah, feel free to add any other questions about that and we can get to it shortly. But cool. So how does ENS work? And this actually might answer some of you guys' questions as well. So as I was saying before, ENS has this core registry. And in this registry is pretty much stored two things, right? A name and a resolver. An ENS resolver is really where all of the data is stored for a given name. And these resolvers can be customized. So they can be the same for every name. Like right here, Greg Skriloff.eth and Alicia.eth use the same resolver. A single resolver contract can store data for as many names as you want, or it can be different. And so the link I just sent, actually, the off-chain demo, I have off-chain demo.eth, and that has a custom resolver, which is how these off-chain names work. And so this might actually be helpful in answering your question as well. In the ENS registry, we have names and resolvers. And then if we take a step further, if we look into resolver OX4976, right, which is the resolver that Greg Skriloff.eth and Alicia.eth uses, inside that resolver is where all of the records for that name are stored. And so the general record types are an address, text record, and a content hash. I'd say the two most common by far are address and text. And really address is like what makes ENS work at the core. And so you can see here for Greg Skriloff.eth in the default public resolver, we call it, I have my ETH address stored, which is OX179A and so on. And Alicia has 2 addresses stored, right? One for Ethereum, one for Bitcoin. And this gets into how ENS is multi-chain, right? These resolvers, the address spec within the resolvers allow you to store multiple coin types. And coin types are a way to have a distinction on what chain and network and coin you're trying to talk about. So if I go into Coinbase wallet, for example, and I want to send Bitcoin to alicia.eth, that will actually work because Alicia has set a Bitcoin address on her ENS name, and that is stored in this resolver. And so you can see here that I can store multiple types of text records. I can store multiple types of addresses. I can also store a content hash. A content hash is basically an IPFS or Arweave decentralized storage like identifier. And that turns my ENS name into a sort of decentralized website. If that excites any of you, then I can dive deeper into it as well. But for the sake of simplicity, I think address and text are really the most popular uses of ENS today, at least. Cool. I see another question just popped in. How does it work for on-chain subnames? Subname will be stored in the main registry, or is it handled by resolver? So there are actually a few different cases. I would say the most, the default case, like if I have gregskril.eth and I want to go create sub.gregskril.eth, I would go and add that to the registry, right? And that subname would also have a resolver, which can be the same resolver and probably would be by default. And then within that resolver, right, it would just be a new entry in this resolver like lookup table. And that ETH address can be something totally different. And that text record can be something totally different. So by default, if I was to create a new subdomain, I would just add a new entry in this ENS registry under gregskril.eth. So it would be sub.gregskril.eth and then specify a resolver as well. But you also can have like a special type of resolver, right? Which basically creates names dynamically, you could say. And so it is possible to have an ENS name that does not exist in the ENS registry. And that's actually how these off-chain names work as well. And this is something called wildcard resolution, of which I will send a link to the docs about that. It is ENS IP10, which is just the type of specs. And so the way this works is my resolver could have custom logic that basically looks to see if certain conditions are met, and then we'll resolve a name even if it doesn't exist in the registry. And again, this is like leaning into the part of the next workshop, but keep asking questions and I'm happy to go into it. Awesome, sounds like that was helpful. And somebody else asked, what if multiple names point to the same address? So that is totally okay. As many names as you want can point to the same address, and that works totally fine, right? I can go into MetaMask and I can send something to gregskril.eth. And you can also go into MetaMask and send something to offchain demo.eth. And I think actually today, those two names happen to point to the same address just because I set up the demo. And that's totally fine, right? But the way you set up the reverse resolution, we call it, right? So that OX179A, so on, reverse resolves into a name, is the user, in this case, me, has to go set my primary name. So at a high level, as many names as you want can point to the same address, but an address can only reverse resolve to one name, and that we call your primary name. And the user has to go set that on their own. It cannot be set like automatically. That can be set at the same time as registration, but it has to be set by the user. And so that primary name is really the answer there. Cool. Sounds like that was helpful as well. So how do people use ENS names? And I guess you might have some ideas by now, or you might be coming up with new ideas, which is always the fun part. You know, everything on the internet is just better with naming. So it's kind of infinite possibilities, but I will just run through a few. So first is, like I said before, this idea of profiles. It's not just a name, it is your portable Web3 profile. And so that is my profile, and these are the records behind that profile. And so just to like expand on what I was saying before, right? All of these records on the side, URL, avatar, description, my Twitter and GitHub and so on, these are all records that are stored in the resolver for my given name. And same with the ETH address and the content hash that I mentioned. So this is just like a visual representation of resolver on the right and really the outcome on the left. And this is another highlight of setting multiple addresses. So Alicia.eth, which is the example I used before, has a list of accounts, future Alicia, Alicia.eth, and so on. These are text records in a resolver. And then the address records, like I said before, accept multiple coin types, multiple chains. You can set your Ethereum address, Bitcoin address, and so on. Alicia has gone ahead and done 6 of those. And so it's just a representation that ENS can support multiple text records, multiple addresses, other cool types of records, and so on. It's a very dynamic and flexible system that I think is cooler than some people that first meets the eye. Another cool use case that we see is some big protocols using ENS to like list the source of truth that these are the official deployments of that protocol. So I'm not sure if any of you guys are familiar with Uniswap, but they are a very big decentralized exchange, right? And their V3 deployments, they have listed on V3 deployments.uniswap.eth. And so that means anybody can go to this name at any time and see the like official contract deployments across these different chains. And it's really just like a decentralized list of how you can use Uniswap. And so it's just like a cool thing that most people don't think of using ENS for, but it's actually a pretty good use case. And so I was excited to see this just like pop up in the wild. Another big one is naming contracts, right? So far, I've talked mostly about just naming individual addresses. And so like my address is gregskrill.eth, but naming contracts is just as useful. So whenever I'm doing some sort of development task on ENS, I'm not going to remember or know where all these contracts are deployed. You know, there are a lot of contracts involved, as you can tell. But I know that they're all named under ENS.eth. So if I wanted to go find the, let's say, registrar that I was talking about before, I just go into Etherscan or some other block explorer tool, and I look up registrar.ens.eth, and it will bring me to the smart contract that is the ENS registrar. And so this one maybe more developer focused, but also on the user side, helpful to see what contracts I'm interacting with. Naming contracts is a really cool one. And this is like a more recent development, I would say. But ENS as usernames just like makes a lot of sense. And that is one of our bounties here as well. And so Farcaster is a decentralized social protocol, which recently enabled the ability to use your ENS name as your username. And so this means on across Web3 social, I can just tag dwr.eth in this example. And again, it's that idea that it's your portable Web3 profile. It works to send ETH. It works to tag you in a post on social media. And it really should just travel around Web3 and the internet at large with you. I'm not sure if you saw recently, but with the whole Twitter stuff going on, a lot of big Twitter accounts have got their username removed and revoked after years of work growing this profile. And that just is annoying to see, and something that we hope Web3 social and decentralized social protocols solves, I guess. And using ENS as your username, using this decentralized username, is a way we can improve that ecosystem. And so this is a really cool one to see. And lastly, we have Web3 messaging. I'd say this falls into a somewhat similar bucket as the Web3 social, but really the idea that you can message any wallet address. Nobody wants to message a random string of numbers, right? You want to message a name, and that name is an ENS name because an ENS name is your portable Web3 profile. And I know I keep digging into this pretty deep, but I just want to make sure the point gets across. Cool. So how do you integrate ENS into your project? This is where I am happy to go into as much technical detail as you guys want and do a coding demo and send some docs links or repo links. Yeah, if you have any questions, now would be a great time to ask, or I will also pull over some a VS Code window and get this set up in the meantime. So
yeah, as Greg says, obviously any questions, feel free to reach out, but it will also be really cool to see some coding. So yeah, Greg, take it away.
So I'm going to send a link to a GitHub repo, which is what I have up on my screen. And it's really just this front-end starter template for Web3 and specifically for ENS, but all of Web3 works, whether it's a mainnet Ethereum application or layer 2 Arbitrum or anything. This will get you off the ground running with Connect Wallet functionality and all that fun stuff. Yes, ENS can be integrated into React Native as well. I'm actually not super experienced in React Native myself, but as far as I know, it's quite similar to React. And so I would say definitely yes. I'm not sure if you have any example repos, but feel free to ask questions in Discord and I can help you poke around or debug or anything that comes up. Cool. And so how many of you guys are building something in React this week? I kind of took the assumption that it would be a lot of you, which is why I might be doing this for my demo, but I'm happy to kind of change some things up if that's not the case. I see some. Next.js 13, React, Svelte. Okay, it should be able to follow along. And cool. Yes, you can ask questions in the Encode Discord. We have I guess a topic, or I forget what Discord calls them, but there's somewhere to ask ENS specific questions. And so I'll be hanging out in there.
Yeah, I think we've called it the ENS zone for anyone who's looking to find that. Greg, there's also been a question in the question channel. How do you deal with typos and phishing?
Cool, good question. So one of the more recent standards, actually very recent, is an improvement of our standardization library, right? And I just added a link in the chat about that. Or I should say standardization like spec rather than a specific library implementation, but it outlines a way to normalize a bunch of characters. And so I think it's called homoglyph attacks, where you have weird characters that look the same, but actually are something else. It avoids stuff like that. It enforces lowercase letters and a number of ASCII characters and such. And so normalization is really the short answer to that of how we prevent against those type of things. Cool. So I'm going to, by the way, keep the questions coming. This is great. I'm going to try and set this up in a way that's not like terribly tiny. Let me know if this becomes problematic for anyone. And so what I'm doing is just starting this Next.js app on the right. So it's good to hear that somebody's working in Next, but really any React sort of ecosystem applies the same. And again, this is the repo that I linked in the chat. I'll run through the basic setup here and then get into some code. So our app setup really just like does the general Web3 stuff. And we have a providers file to do that. And so what I'm doing here is connecting to Wallet Connect, which is a way, I guess like a protocol that allows you to connect your wallet to different types of applications. It also works with MetaMask and so on. And then we are using WAGME, which is a set of React hooks for Ethereum, including some nice ENS stuff. And then lastly, we are using RainbowKit, which is a really nice library that just takes care of a bunch of stuff that you don't want to deal with, is my easy way to explain it. And it works great with WAGME and handles the Connect wallet state and everything like that. So I'm a big fan of these tools, RainbowKit and WAGME, and I highly recommend using them, which is why we have it in our front-end starter template. And so once we have these providers, we have to wrap our application in them. So we wrap it in a WAGME config, and then we wrap it in a RainbowKit provider, And this basically exposes all of the hooks to our application so that we can access really all of Ethereum, which is pretty exciting. And so not too hard to set that up, but it's already taken care of for you in the template. I just wanted to show you that so that you don't think the hooks work just on themselves. And then lastly, I'm using Thorin in this application. Thorin is right here, our ENS design system and component library. Whether you're building something on ENS or not, I think it's just a nice way to like quickly build stuff that looks cool without having to style every single tiny like atom, you know? And so I'm a big fan of using this in all types of applications and highly recommend it. So I will drop a link in there and you'll see that in this demo, I use it quite a bit for different components and it just makes designing things a lot easier. Cool. And so this is our general app setup. And then in the index page is really no like Web3 logic. It's just these links to these two examples. And so if I visit this input page, and I will open my input page on the left here as well, and then close the sidebar, this is actually where we get into the Web3 related code. So the demo here, which I'll then delete and kind of walk through from the ground up, is an input that accepts both any sort of Ethereum address or really EVM address. So that means a layer 2 as well, like Arbitrum, or an ENS name. And so I can type in gregskrill.eth and it will load that address right here. Or if I want to type the address itself, then that works as well. And this goes back to the idea before that I said, anywhere you read or write an ENS name, or sorry, anywhere you read or write an Ethereum address, or really just like a crypto address, you should be able to also read and write an ENS name. And so we will go and remove this code and build it out from scratch. And hopefully I don't mess anything up. But I see someone typing, so I'll let them get their question out before I do that. What if you type an address that does not have an ENS name? That's also totally fine. ENS is optional. It's opt-in. Nobody has to use it. And so we want to accept any sort of EVM address. So I'll show you if I go to Etherscan, which is an Ethereum block explorer, and grab some random address. Oh, this one happens to have an ENS name. That's kind of cool. But let's see if I grab this, which does not have an ENS name, and I go paste this into my little demo, it will also work and just like verify that it is some sort of address. Certainly does not need to have an ENS name. Cool. So I'm going to go ahead and delete all of this logic and we'll basically rebuild it. All right, so I'll keep the skeleton here. And then you can see what we have. It's like the most basic React page with 0 Web3 logic, and we're ready to go. So this page is just input. It has some layout stuff with a container and a card, but no logic, no hooks, no nothing. And what we're going to do here is build out what we just had and show you how relatively simple it is. And I'm going to open something on my other screen as well, just so I don't mess this up, because demos are always hard. Cool. So what we're going to do first is add an input, right? And Thorin, which again is that component library I mentioned before, has a really nice input component that just makes it so easy to do this stuff. I love using it. And so we're going to add an input here with a few.
Sorry, Greg, I'm just wondering if you can zoom in ever so slightly on the left-hand page, just to make it slightly bigger. Perfect, much better. Thank you.
Cool. Yeah, thanks for mentioning. What if I go, is that too big? Or does that look good?
That looks good to me, thank you.
Okay, great. I will expand the code a bit. Thank you for mentioning that. So we have an input here, which requires a few props, I think that would be like a placeholder, right? Which we're going to say is an address, or let's say placeholder is an ENS name, but again, also does accept an address. And we'll say that the label is address or ENS name. I'm going to save it, and here we go. We have a great looking input with the label and everything. And so now we want to keep track of like what is in that input, right? And so we're going to use a React use state to do that. So we're just going to say input, set input, and then import use state. And if you see these recommendations popping up, I'm a big fan of GitHub Copilot, and I don't know if you guys are as well, but sometimes it just codes for me. So if I'm skipping over some things, let me know, and I'm happy to take it slower, but big fan of Copilot. Cool. And then right now, this input state doesn't actually have any info in it because we're not using it. So I want to change that, right? And what I'm doing here is, oh, sorry, my screen's a little too small for some of this stuff. When I'm typing something in this input field, then I want to basically update the input state variable to have that. So now if I'm just going to go ahead and console log the input, I'll open up a log on the right-hand side. And when I'm typing stuff, then I know this input state is being updated. Cool. So step one, have an input that we can like use in other places because it's a variable up here. And then since we're going to be resolving ENS names, when a user types something in, we want to debounce that input. And basically what that means is on every single key press, I don't want to be making an HTTP request to resolve an ENS name because that's just like a lot of network requests. And so debouncing it enables me to kind of slow that process down and only make an HTTP request once the user stops typing for a second. And so I'll show you what that actually looks like, right? And so I'll just call this debounced input, and there we go. Copilot is going to write it for me. I will go ahead and import use debounce from usehooks-ts. This is another library that I use by default in just like a ton of projects. I really love it. I will send a link to it as well if you are trying to follow along or just curious. Makes it super easy to debounce your inputs. And the reason you might want to do that is this. So I'm going to log both the input and the debounced input. And what this means is I'm going to type Greg. You'll see that the input is being updated every single keystroke, but the debounced input is only being updated every 500 milliseconds, or after I stop typing for 500 milliseconds. And so what we're going to use this for is to only make the HTTP request to resolve an ENS name if the user stopped typing for a second, so that we're not just like firing these off rapidly because that's unnecessary. Cool. So we have input, we have debounced input, and that is all nicely connected to our good-looking input. And so now what we're going to do is use some of those Web3 hooks from the WAGMI library to resolve an ENS name when we think it might be an ENS name. And here is where it's important to take back the understanding of ENS names are not just .eth. A lot of people make the mistake here of doing like if input includes .eth, then try and look up an ENS name. But that won't include a lot of other types of names, like some of these off-chain names or DNS names and so on. So just to make it super clear, we're going to have a variable that tells us if it's a potential ENS name, right? And the way we want to do that, so Copilot is wrong here. We do not want to check if it ends with .eth. We want to check if it includes a dot at any point, because any like dot separated string we want to treat as a potential ENS name. And we're going to use this in a second to then again trigger those HTTP requests. So far, is everybody following? Do we have any questions? I figure before we include the actual hooks and the Web3 logic, this might be a good, okay, and no comments. I'm going to assume that we are good. Go. So now we want to use some of the Web3 stuff. And so to do that, we're going to import a hook from WAGMI called use ENS address, right? The name kind of speaks for itself. We are going to pass in a name and get an ENS address, if it exists, of course. And so the way we do that is WAGMI outputs a few props. Data is the one that we really care about the most here. And I guess I'll also use floating. And in here, we're going to use the hook, use ENS address that we just input before. And to this hook, we're going to pass a few things. Most importantly, we're going to pass the name, but we only want to pass that name if it is a potential ENS name. Otherwise, we're going to be making unnecessary HTTP requests, and that's just never fun. So Copilot seems to be right here. If it is a potential ENS name in the input or in the debounced input variable, again, to slow down those requests, then we will kind of like pass the name into WAGMI. Otherwise, we're going to keep it undefined. And the reason we do that is because if a name is undefined here, then WAGMI simply won't fire. And that's exactly what we want. And then the only other thing here that we want to include is a chain ID. And this goes back to a question that somebody asked before of if I'm building an application on a layer 2, or that mainly uses Arbitrum, for example, and you want to look up an ENS name, my response was, you always want to use mainnet Ethereum as the source of truth here. And so WAGMI allows you to configure that, right? If you specify chain ID 1, then all of your ENS, or every instance of this hook running will look at mainnet Ethereum, which is chain ID 1, over whatever chain your user is connected to. And so if you want to use ENS properly and not on a testnet or something else, then you want to make sure you're always specifying chain ID 1 to look up the address. Cool. So this will now work. It will look up a name. And I'm just going to add a comment here to make it super clear that if we have a potential ENS name, try to resolve it. And emphasis on try, because not all of these names will exist. Like I could type in some random stuff here. I'm pretty sure that this name .eth or .anything is not registered. And so it will just return null or undefined or something. But this isn't guaranteed going to return an address. So we just want to try it if it's a potential ENS name. Awesome. So now I'm going to console log this data to see if something is being returned when we type stuff in this input. So I'm going to type in a bunch of random stuff. You'll see it is undefined. And if I type in gregskril.eth, then you'll see after that 500 millisecond debounce, it makes a request and it returns the data, which is the address for gregskril.eth. And that's exactly what we want, right? If I type in like the address directly, which was another question before, it simply won't return any data, but we still know that it is an address, and we'll add some logic for that in a second. But this is great. It only fires when there's a dot in the name, and that data is resolving perfectly. So Nick resolves to a different address than Greg. Cool. And that's like really all it takes to look up an ENS name, which is quite simple, like 3 or 4 lines of code. But now we want to handle the logic of like, is an address submitted, or is an address entered directly, or is it an ENS name? And so here we're going to have a variable called address. And this is going to be like if we have an ENS name, use that. Otherwise, use the input directly. Right, and so this is just going to check, or it's going to use another tool, I guess, from VM, which is installed alongside WAGMI. And we're going to check if the supplied, basically, input is an address itself. Right, so we're going to do this by passing debounced input into isAddress. And if it is an address, then we're just going to use that directly. So we don't have to look up an ENS name at all. But if the supplied, like if the input is not an address, then we are going to assume that it can be an ENS name. And therefore, I'm going to use that, basically, this data. Right? And just to make it more clear, I'll rename data to ENS address, and I'll rename loading to ENS address is loading. So I didn't change any logic there. I just renamed these things. And data is no longer defined because we renamed it to ENS address. And so what this is saying, I'm going to expand this window just a little bit more. What this logic is saying is if the supplied input is an address itself, we're just going to use that. Otherwise, let's see if it is an ENS address. Cool. And this is pretty much all of our logic, right? What I'll do here is one thing we like to do is if it is an ENS name, and so if I've input Greg Skriloff, we want to show the user the address as well as like a little side note or description just to make sure that they can kind of double check themselves. And so the way I do that in Thorin is just by adding a description. So I'm going to say if we have an ENS address, then I'm going to show the address that it resolves to. And so you'll see here, that means if I type in an address directly, then that itself just works, right? But if that does not, if they pass in an ENS name, then we'll show the address as like a little side note just for that extra confidence. Okay, those messages are good. I see we have a few minutes left, so we're getting to the end of this. And I will just add some last logic before to kind of catch up to where we were on the demo before I deleted stuff. I'm going to add a button from Thorin that is, I'm just going to put a button in it and disable it if we don't have an address. And so we'll see what that looks like in a second. Refresh this page. Right now, there's no address. There's nothing inputted, either an ENS name or an address at all. And so our button is disabled. But if I do have an address, either by way of an ENS name or by way of an address itself, then this button becomes enabled because we have the address that we want. And so this is like a very typical sender flow that you would see in crypto, an input field that accepts both an address or an ENS name and verifies that the address is legit. And this should bring us basically up to speed with where our demo was. I will send a link to that specific page in the repo as well. But with 5 minutes left, let me know if you have any questions on that quick demo, and I'll close it out a minute after that.
Amazing. Greg, thank you so much. I think we'll only have time for a couple of questions. If there's anybody who has any more technical questions, feel free to drop it in the chat. But I'd like to potentially start off, Greg. Obviously, many of the participants of this hackathon are all students. And so I just wondered if you had some general advice for anybody looking to get into the Web3 industry.
Yeah, great question. So I actually kind of got deep into Web3 while I was a student myself. So that's why this hackathon feels extra special and at home to me. I was in university and just like stumbled upon a bunch of Web3 stuff on Twitter that caught my eye and seemed interesting. Joined some Discord groups and just like got involved. You know, it was no pressure. I would encourage you to take the same approach, like follow your curiosity and don't force yourself into any situations. I think things that catch your eye naturally will just like opportunities will present themselves. The first thing that I did when I got into Web3 was join a Discord group for an NFT project. And they were doing some manual process to like give away these NFTs or something. And I kind of just noticed that that was a pain point and asked if I could make a Discord bot that automated this for them. And they said yes. And that really just like kickstarted my journey into Web3. And I didn't do it because I felt any pressure, anybody asked me to, or anything. It was just like fun. And that's like, I've tried to follow that as much as possible ever since. If something seems fun, just do it and see where that takes you.
Amazing. Yeah, I think that's some really good advice. Hopefully everyone's having a lot of fun on this hackathon as well and kind of developing their skills. So hopefully a nice link there. Maybe one more, if we do have time, is just obviously you gave some teasers ahead of your session on Friday. I see lots of people very grateful in the chat, so I'm sure they would love to attend again. Perhaps you could just give us a slight overview of potentially what to expect in that session.
Yeah, good question. So I plan to dive a lot deeper into the ideas of like off-chain subnames and really the underlying tech that like enables that. And what that allows you to do is have more flexible ways of distributing names, of updating names, of I see somebody asked a question about chat, about giving names to your users so that they have a better chat experience. And that's actually exactly what Coinbase Wallet does that I mentioned before, right? I'm messaging an ENS name that if a user already has a .eth, they could use that. If they don't, you can issue them a new name for free via this off-chain system that I'll be talking about. And so I hope that answers kind of two questions in one, of like a lot of more flexible, scalable, like dynamic, advanced ENS stuff that's more cutting edge. Of which one example could be chat apps. So yes, to whoever asked that question, chat applications are great.
Perfect. Thank you very much. For anyone else with any more questions, I've dropped a Discord link to the ENS zone. Greg's very active on Discord, so I'm sure we'll be more than happy to help for any of those. But yeah, Greg, I'd love to say thank you very much. I'm sure I speak for everyone when I say that was extremely insightful. Hopefully provided a lot of context for those building projects and those people looking at the ENS bounties. So thank you very much for that. We look forward to your next session on Friday. For our participants still in the meeting, we do have another workshop session in half an hour's time, which is a coding tutorial using Arbitrum Bridge. So it'd be really great to see you all there again and to go through another tutorial. But Greg, thank you very much. Really great to see everybody, and thank you too for your insightful questions. So thank you, and we'll see you all soon.
Thanks.